let's look at how we formulate the mesh current equations. And since each mesh currents relate to each mesh or loop, we need to write the Kvl equation. We start with the Kvl equation for each loop. That means we write the if this loop does not really have any current sources. If there are voltage sources, in this case would be easy. And so we just write the Kvl equations, and by using the voltages across each element, right? And the way we write these equations is we use the voltage drops across non-source elements. The sum of this would be equal to the voltage rise of the voltage sources in this mesh, right? And then the second step is we write the element constants so that we can associate the voltage of each element with the mesh currents. First with the element currents, and we also know how the element currents is related to the mesh currents, so we can write the equation in the second step. The third step is just replace those element voltages by the first equation, the Kvl equations, by the element constraints we had using the mesh currents. So let's look at an example and see how this really works. Hopefully that will make sense quickly. And so I have the circuit, the same circuit actually I used. But here we do the mesh current analysis. We're trying to find the three mesh currents. I already labeled these. So I sub 1, I sub 1, I sub 2. So these are three meshes. So this is the mesh 1, and the mesh 2, this is mesh number 3. So I have three meshes. I try to find the three mesh currents. Okay. And in this case, let's see. We want to find. We want to write the Kvl equation first. So the step 1. And Kvl equations for the Kvl equation for mesh number 1 and 2. We don't write the Kvl equation for number 3 because we don't really know the voltage across that current source there. For mesh number 1 and mesh number 2. And in this case, I already labeled the voltage elements, and you could label any way you want. Okay, it doesn't really matter because they will be replaced, right? So they will be replaced, so they will disappear from the final equation. It doesn't really matter. So the way I label here, just I chose a way to label. And so let's see the first mesh, the Kvl equation for mesh 1. And the convention we follow is voltage drops once we choose the reference direction. In this case, the reference direction we use the direction for the mesh currents. Okay, so in this case we choose we already had the mesh current chosen for the clockwise direction, so we use the same clockwise direction to write the Kvl equation. Remember, we write the voltage drops across each non-source element. For mesh number 1, it's easy because there is no voltage source, right? In this case, we have the voltage drop. Let's start with the 10 ohm resistance. That's V sub 1, 2, right? And that's the voltage drop from plus to minus, or from left to right, right? So that's the voltage drop, V sub 1, 2. And then we have this 2 ohm resistor. So this is V sub 2, 0. That's another voltage drop. And so now we go from minus to plus. This is the voltage rise of V sub 10. We need a voltage drop, so we need to put a negative sign here. And so in this case, we don't really have any voltage source. If we do, we will put a voltage rise with that source on the right hand side of this equation. So here, make sure you understand this is a drop, and this is another drop, right? So here, this is another drop. So you add all the voltage drops. The first equation is easy. A second one for the mesh number 2, and I have the voltage. Again, here we follow the clockwise direction. So in this case, let's start with the inductance impedance. So that's V sub 2, 3. That's a voltage drop, right? And I'm gonna put the voltage source voltage on the other side equation. So on the left hand side equation, I would put all the voltage drops across the non-source elements. So then we need to do with the 2 ohm resistor. In this case, from minus to plus, that's V sub 2, and that's a voltage rise of V sub 2, 0, right? We need a voltage drop, and therefore we put negative sign there, negative V sub 2, 0, equal to the voltage rise. The voltage rise following the direction, that should be equal to negative 12. So this is the voltage rise. Because from here to here, that's the voltage drop of 10. So that means the voltage rise is negative 12. Okay. If you're still getting confused about the voltage rise and drops, go back to lecture number 2. Okay, you really need to get that concept clear. In this case, this is the voltage drop, right? Because from clockwise direction or from the bottom here to the upper, and you get the voltage rise of V sub 2, 0. We need a voltage drop on one side equation. So this is another voltage drop. So we are writing this kind of KVL equation in third flavors, right? Remember, and the one side equation is sum of the voltage drops. The other side is the sum of voltage rises. If you have multiple voltage sources in one mesh, you're gonna add all of the voltage rises across these sources, and that's it. So this is step 1. At step 2, we need to write the element constraint, just as we did before. So I'm not going to write all of them. So maybe write a couple of them. You get the idea. So step 2, I write the equation. Let's see the element equation. So let's see V sub 1, 2, V sub 1, 0. This element, this voltage is equal to I1, 0 times the impedance, right? Negative J5. And we also want to replace this element currents by the mesh currents, because that's what we really want to. And so in this case, I have negative I1 times negative J5. Let's see. Need that negative I1? Yes, negative I1 plus times the negative J5. Right. So you can do this for all the other elements. So let's do another one. Maybe V sub 1, 2. The V sub 1, 2 is going to be equal to the I sub 1, 2. By the way, in this case, while I sub 1, 2 and V sub 1, 2, they following the passive sign convention, right? So therefore, that's just equal I times Z. And this 10 ohm and I sub 1, 2 related to the mesh currents by I1 minus I3 and times 10. So on and so forth. You can write all these equations. And step 3, you substitute all these equations into the first KVL equations. Step number 3. So the KVL equation, let's see, the first one you have negative V sub 0, right? You have negative V sub 0. Yeah. So you have V1, 2. Okay, we start with the V1, 2. V1, 2 is this one here. So you get I1 minus I2 times 10, right? Times 10. So let me put 10 here. And then you have the V20. V20 actually is plus, V20 actually is I1 minus I2 times 2. So let me put 2 there in front of this. So I1 minus I2. And V sub 1, 0, that's negative V sub 1, 0, right? Negative V sub 1, 0, actually another negative. So they get quite a few negative sign here, but I just want to keep this so I don't confuse you. And in this case, that's equal to 0. You actually can collect the terms. So I did the collect terms in the in the Google Colab notes, so you can check on that. And for second mesh, and we would have for a second mesh, let's see, we would have V23, that's going to be equal J3 times I2 minus I3, and for V sub 20, V sub 20, I didn't write that one, so that's actually minus V sub 20. V sub 20 is I1, so it's 2 times I1 minus I2, and that's the all the voltage drops, right? And that's going to be equal to all the voltage rises, so negative 12. And now we have three unknowns, I1, 2, 3, right? We are missing one. The missing one, the third mesh. That's, we cannot write Kvl equation, but we can utilize the element constraints. The element constraint, basically I3 should be just equal to negative J2, that current source, right? So that's equal to negative J2, the current source, because the reason for that is this in opposite direction, right? So this, therefore you get all three equations, and you can utilize the Python, check the Python. So the Python, we have the same example here. These are the things after you substitute. You can organize that in the form of each of these, actually in the form of the I1, I2, and the unknowns. You collect the terms, and you can also put them in matrix form, and you can solve this equation either using symbolic without a matrix form, or you can solve the equation using the matrix form. You got the same equations, you got the same results. Okay, so that concludes the lecture number 5. There's quite a bit stuff we covered. So any of these concepts kind of confuse you, make sure you go back to the previous lectures, clear that up, because otherwise this is going to come back to you when we talk about the Laplace transform. Okay, so even after this course, if you don't not clear, so this will come back to you in the other courses when you go 300 level courses. So make sure you understand the concept. Okay, that's it for today. Remember, no matter what you do, just keep going, never stop. See you next time.